Hi, my name's Clayton. My wife and I are building a house, and we're going to be going all LEDs. We've noticed a lot of flicker in recent times in our current house, and I wanted to make sure that it didn't duplicate any of those flicker problems. So I have learned a lot exploring things in the past few days, and I thought I would make a video to share some of that with you. Part of the problem that I found when I was searching is there's a ton of repetitive information online, and if you do find something that's unique, it's oftentimes based more on just a subjective opinion or sometimes even a misunderstanding of how things work than the objective properties of the devices. And I couldn't find any actual reviews on dimmers. Most of the reviews that just lead to Amazon listings, and they all seem to have similar and less than stellar ratings. So what is it with dimmers? I thought I would do a roundup on those. This is going to be a long video, but you can skip ahead. If you're just interested in dimmers, you can jump ahead to section 5, and I will put those numbers right down here. And if you just want to find out what I learned through all of this, you can jump ahead to the final section 6, and I'll give you the summary of everything. But let's get started. Let's take a look at what this thing looks like with basic AC on the oscilloscope. So this is our oscilloscope display. It's showing voltage on the vertical axis and time on the horizontal axis. So as the voltage, the purple line is 0, so as the voltage rises above 0, gets up to about 170 volts or so peak. Each grid is 50 volts. And then it falls to the same amount below. And then it comes back to 0. So we're looking at 4 cycles of a 60 cycle waveform. Each horizontal grid is 5 milliseconds. So a complete cycle takes about 17 or so milliseconds. So when we want to dim a bulb, what we want to do is we want to remove some of this power. Everything under this envelope here and below this envelope here is power that's going to our bulb. So what's in a dimmer switch anyway? I've taken one apart, and we can see the inside is composed of a small circuit board. There's a slider here that sets our brightness. A few components, resistor and capacitor here, which we use to delay turning on the triac. The triac is a solid state device. It's in the bottom of this one. You can see it right here. This will generate some heat, so it's always mounted on a metal heat sink, and that's why these things always have this chassis around them to dissipate some of that heat. But essentially what's happening is this device turns the power on and off on every cycle. So this thing switches 120 times a second, and we'll look at that waveform now. So let's take it through a dimmer switch now, which I have on channel 2, which is this yellow line. So we can see the effect of a triac turning the power off until a few seconds or a few milliseconds later, and then when it turns on you get this vertical line. And as we dim the triac down, as we dimmer down, you'll see that our time delay is longer and longer, and our voltage effective voltage continues to drop, and our lamp is dimming until we get down to a very dim. And you can see basically that the power we're delivering to the bulb, which is the envelope under the yellow, is getting smaller and smaller. Now, one thing to consider about those triacs is that is the ultimate switching device for all dimmers. Even if you have a smart dimmer or any brand of dimmer, that essentially will be the end result of what turns the power on and off. That circuit board in front of it will vary. If it's going to be a smart dimmer, it'll have all kinds of circuits maybe to connect to your Wi-Fi and everything else. But everything I'm showing you on the scope would apply to any type of dimming device for your AC. Here's a bulb you can actually see labeled on the screw thread as being not for dimmable use. So this is not a dimmable bulb. Let's put it into the socket, see what happens when we put it on a dimmer. On the Lutron, comes on at a low level. Maybe a little bit of shimmy, but not bad. As it comes up to smooth, and does about as well as a dimmable bulb. This is a stairway fixture. It's designated as being a dimmable fixture. If I run it at a low level though, you'll notice, hopefully it shows, there's quite a bit of flicker in it. I'm on the legacy dimmer. As I bring it up a little bit, even at marginally brighter, it's still flickering until we get up to almost midway before it stabilizes, and at that point it starts looking reasonable, although not great in my opinion. At full brightness at about here, or really from full brightness down to maybe half brightness, it's pretty good. It's pretty stable, but at very dim levels it flickers. Alright, let's try it with the Lutron fixture. Oh, at low volume, it's sort of unstable. It's flickering quite a bit. At minimum brightness, it flickers about the same, and it's actually more wavy and more out of control than it was with the legacy fixture, legacy dimmer. Bring it up to about halfway or so, stabilizes, so virtually the same performance. Alright, so we've seen how we can dim one of these incandescent bulbs. This is basically a device that's been around for 100+ years. It's actually more of a heater than a light bulb. Most of the power goes into creating heat by a short-circuited tungsten element in there, getting so hot it radiates heat, or radiates light. The LED of modern day is a completely different device. It's an electronic component that drops electrons across the silicon junction and emits photons. But heat is the enemy of this guy. But we've got to get rid of a lot of power, and I'll show you that in just a minute, and we have to do it without creating heat, and if we do create heat, we have to dissipate it. Now these modern bulbs are amazing. They're getting all the electronics for the power supply built into the base. We'll take a quick look at that, and then we'll jump on the scope and see what the power differences look like for these devices. This display is showing 12 volts DC imposed on our AC waveform. The yellow line is our 12 volts, so it gives you a good idea of the relative scale of power that we have to convert. We've got to basically change the red waveform into the yellow waveform in order to drive our LED. So that means that we have to have a circuit, and this circuit winds up being in the bulb itself, to remove the bottom portion of the waveform, or possibly flip it up to the top, but that takes more circuitry. And then we've got to reduce the top part down to about this level. So if you think of that, you're basically looking at that yellow line would wind up being a dashed line instead of a solid line. And that's where some of the flicker problem comes from. What a pile of dimmers. Well, let's start quickly with the legacy one. Not much point in reviewing that one. If you have it and want to continue using it, go for it. Then we come to the only switch I didn't really talk much about, was this antiquated Cooper switch. This one actually had one feature that all of the switches should have, and none of them do have, and I think this is a discontinued one, is when you went to full brightness, it actually had a switch that bypassed the dimmer circuitry and put the full AC on. So that's a feature that every dimmer switch, in my opinion, should have. None of them do. Alright, let's get to the Fight switch. This one's available from Costco. There's a very nice little blue display on the side. It's a regular depth switch, but it does have the wires, so you have to put the wing nuts on the wires. Then you have to make sure that those are somehow fitting in the box, and you cram that all in. So these are kind of a pain to install. But otherwise, it's an okay switch, priced in the mid-range. There's a ton of them like that. The Lutron was one of the most stable waveforms in the bunch. Produced a very clean pattern on the scope, but it didn't really reflect any improvement performance for the LED flicker problem. In a standard two-way configuration, it's a great switch to choose. That would be the 2-wire configuration. If you have 3 or more switches, I have some concerns. Those concerns revolve around this blue connection. This is a control signal, and it's made to communicate between multiple Lutron dimmers. You can use this dimmer with a conventional 3-way switch, but the wiring is unconventional. You'll have to go to the other switch, combine the neutral and the line or the load together with a jumper, and put that jumper wire on that switch. It's very strange, and then you have to come back to this switch and make sure that it's configured properly with some combinations of long-term presses and setting a value on the dimmer indicators over here. If you have 3 or more switches, you're going to have a 4-way involved in that, and I don't know if the switch can do that or not. I went to the Lutron site, tried to figure out how to do it. All of the pictures that they showed was 3 Lutron dimmers where you connected them all on the common with the blue. They didn't have any pictures or schematics that I could see that showed how you would do it with a traditional 4-way dimmer switch. So in general, this is a good choice for a single location if you need those features for slow up, slow down dimming, or push it, the light stays on while you leave the room and it dims down. Those are neat features, but if you don't really need those features, or you have a 3 or 4-way switch, I would avoid the Lutron. Here's another switch. This is the L-Grap. You can find these on Amazon. Some neat features about this switch are that it has clamp grip, so you can put the screw in instead of having to wrap it around the screw. You can put it in and clamp it down, so it's very secure and much easier to install. Not only that, it's much thinner, so there's way more room in the box, and it's still got the slide switch on the side. It also has a little indicator light in it. It's the cheapest of the bunch, and this is basically the one that I've decided to go with. This is an occupancy sensor, but it's one of the no neutral required solid state versions. And when this switch goes off, I've got a non-dimmable bulb in the fixture, and it starts this flicker problem. A solution, there's a couple of solutions. One is to put another bulb, or to use dimmable bulbs, and that solves it so that when it comes on. But you're still losing that 5% of brightness by using this particular fixture because it's switching through the triac. When you're shopping for occupancy sensors, make sure you purchase one that has the white neutral wire required, and you'll know it will have this relay click. Hey, you made it to the summary. Congratulations. I'm glad you're here. I'm sure you probably are too. Anyway, what did I learn out of all this? Well, basically, dimmers are dimmers. They really haven't changed effectively all that much since they came out in the 70s. Some front-end features, but the actual switching and dimming still done with a triac, and it's not that much different. There is no perfect dimmer that I found. All of them will lose 5% or more of the brightness on full brightness. That's a feature that really should be implemented, in my opinion. Dimmable bulbs is sort of subjective. I'm not sure if there's a standard for it, but some things that are rated dimmable still have some flicker to them, and you're not going to be able to fix everything with a better dimmer switch. So if you have a problem, you're probably going to need to fix it with a better fixture or a different fixture. If you're using an occupancy sensor, make sure that it's a relay type, not one that's switched with a triac. If you're in a 3-way situation where you have 2 switches to control a light, I think I would recommend staying away from the Lutron brand. That deal with the control wire is really strange. You have to rewire all the other switches in a non-standard way. I actually had a friend call me out because he had an electrician come out and he was confused, and the bill was very expensive, and when he left he had some switches labeled do not use. So if you do have a desire for that, an electrician to do it, be sure you qualify before they come out that they know how to do a Lutron. I think that's pretty much what I found. I hope this is helpful, and have a great YouTube day. See you next time.